All right. So in this section, we're learning about algebra and limits. And for those of you who have to take Math 120, Calc 1, right? There's a lot of algebra in Calc 1, and so it's important that you have good algebra skills in Math 120. So you use this section to enhance your algebraic skills for those of you who have to take Math 120. So yesterday we finished the problems on page 4 of the lecture guideline, lecture handout, and now we're going to do the problems on page 5, and we're going to be rationalizing the denominator and rationalizing the numerator in a quotient involving x. So let's review for just a moment what we mean by rationalization. Okay? So from the feedback that I've gotten from students, some of you were taught how to rationalize a denominator in high school. Okay? And so we will just review that briefly. And then for those of you who weren't taught it, right, now's the time to learn. Okay? So let's say we solve some problem, and for our solution we get x is equal to 2 over the square root of 3, right? That fraction. Now, back when I was a high school student and an undergraduate, it was the standard back then to rationalize denominators, right? You didn't write the final answer with the square root in the denominator. Okay? So you got rid of the square root in the denominator. So in this case, how we get rid of the square root in the denominator is to multiply top and bottom by square root of 3. So when we do that, we have 2 times the square root of 3 over square root of 3 times square root of 3. The numerator remains the same, 2 times the square root of 3, but square root of 3 times square root of 3 is 3. So that's what rationalizing a denominator is, okay? We got rid of the square root in the denominator, but then now the square root's in the numerator, okay? Now let's take a look at an example where the answer to our problem is 2 over square root of 3 minus 1, okay? Now, you can't simplify that in the denominator. Square root of 3 is an irrational number. 1 is a rational number. Okay? So to get rid of the square root in the denominator, we're going to multiply top and bottom by the square root of 3 plus 1. And so when we do that, we have 2 times the square root of 3 plus 1 over square root of 3 minus 1 times square root of 3 plus 1. Okay? So you notice that the difference between these two quantities is I just changed the minus sign here to a plus sign. When you do that, this is called the conjugate of this quantity, square root of 3 minus 1. Okay? So square root of 3 plus 1 is the conjugate of square root of 3 minus 1. So this first factor in the denominator is of the form a minus b, and the second factor is the form a plus b. So we learned on the bottom of page 2, right? We learned about difference of squares. And this boils to a difference of squares, a squared minus b squared. So in simplifying this, the numerator remains 2 times the square root of 3 plus 1, but this denominator boils to a squared minus b squared, a difference of squares. Well, a in this case is square root of 3, and b is equal to 1. So a squared is square root of 3 squared, and b squared is 1 squared. Now you do the order of operations in the denominator to simplify. And the numerator remains 2 times the square root of 3 plus 1. Square root of 3 squared is 3. 1 squared is 1. And so the denominator simplifies, right? 3 minus 1 is 2. And so the denominator simplifies to plus 2. And now you can see 2 is a common factor in the numerator and denominator. And we're left with square root of 3 plus 1. So this fraction over here, this quotient, has the same decimal value, use your calculator, as square root of 3 plus 1. Both square root of 3 plus 1 and this quotient have the same decimal value. Okay. How many of you learned how to rationalize in high school? I'm just curious. Some of you, right? Not many of you. Okay. So we're going to, in the problems that follow, right, we're going to be using this technique, right, to rationalize a denominator. Okay. All right. But before we do that, let's formally define what a conjugate is. So A and B can be real numbers or variables, doesn't matter. So the conjugate of A plus B is A minus B, right? So to get the conjugate of A plus B, you just change the plus to a minus sign. And the conjugate of A minus B is A plus B. You get the conjugate of A minus B, you just change the minus sign to a plus sign, okay? We need that in rationalizing denominator or numerator in the examples that follow. All right. So in the first example, we're going to rationalize the denominator of x squared minus 16 over square root of x minus 2. So again, rationalize the denominator means getting rid of the square root in the denominator. Okay? So we're going to multiply top and bottom by the conjugate of this denominator. So we have x squared minus 16 times the square root of x plus 2, because the conjugate of square root of x minus 2 is the square root of x plus 2. And in the denominator, we have the square root of x minus 2 times the square root of x plus 2. Okay? So when we multiply top and bottom, right, by square root of x plus 2, we're just multiplying by 1, right? So anything divided by itself is equal to 1. We're not changing the problem. Okay? So the denominator is of the form a minus b times a plus b, where a is equal to square root of x and b is equal to 2. Okay? So the denominator, well, let's go with the numerator. So in the numerator, right, we have this factor x squared minus 16. You should recognize that as a difference of squares. You can write that as x squared minus 4 squared. And from page 2, for the difference of squares, that factors into x minus 4 times x plus 4. And then we multiply that by square root of x plus 2. The denominator, right, a minus b times a plus b, boils into a squared minus b squared. Well, a in this case is square root of x, b is 2. So the denominator boils into square root of x squared minus 2 squared. Well, the denominator square root of x squared is just x, and 2 squared is 4. So the denominator just simplifies to x minus 4. And now you can see x minus 4 is a common factor in the numerator and denominator. And those two factors cancel as long as the factor x minus 4 doesn't equal 0. Because if it equals 0, you're dividing by 0. And so when you solve for x, you get x can equal 4. So this quotient simplifies to x plus 4 times square root of x plus 2 under the condition that x doesn't equal 4. Right? You can only cancel those two factors only if x doesn't equal 4. Any questions on that, ladies and gentlemen? So you notice we got rid of the square root in the denominator, right? We still have square root. It's just not in the denominator. Okay. And now we can evaluate the limit. We have the limit as x approaches 4 of x squared minus 16 over square root of x minus 2. And so when you do the direct substitution, you have 4 squared minus 16 over square root of 4 minus 2, which numerator equals 0, denominator equals 0, and 0 divided by 0 is undefined. But the limit may still exist. So this quotient is undefined at x equals 4. But the limit may still exist, okay? Because we're interested in the value of this quotient as x gets close to 4, not at equal to 4. Okay? So since x never equals 4 in the limit, this quotient simplifies to what is in the box up here. So this is equal to the limit as x approaches 4 of x plus 4 times the square root of x plus 2 and now when I do the direct substitution, put in 4 in for x, I have 4 plus 4 times the square root of 4 plus 2. All right, we're doing the direct substitution now. Four plus 4 is 8. Square root of 4 plus 2 is 4. We have 8 times 4, which is equal to 32. So the closer x is to 4, the closer the value of this quotient is to 32. Even though this quotient is undefined at x equals 4. Okay. Remember, there's a difference between at and near. Okay. So what does this tell us? In the graph of this quotient, the graph of this function, there's a hole in the graph. And there's a hole in the graph at the point 4, 32. 4 is the x coordinate, 32 is the y coordinate. Okay. Any questions on that, ladies and gentlemen? All right, let's do another one. This one is a little bit more challenging. Okay. Now, it turns out I probably shorted you space. So you can do the rationalization on this page, and then if you have to, flip over to the bottom of the next page for the limit. Okay. All right. So we have x minus 1 over 2 minus the square root of x plus 3. We want to rationalize the denominator, get rid of the square root of the denominator. Okay. So don't worry about what's under the radical, under the square root. The conjugate of 2 minus the square root is 2 plus the square root. Okay. So we're going to multiply top and bottom by 2 plus the square root of x plus 3. Get rid of that square root. So we have x minus 1 times 2 plus the square root of x plus 3 over 2 minus the square root of x plus 3 over 2, the denominator, 2 minus the square root of x plus 3 times 2 plus the square root of x plus 3. Again, we're just multiplying by 1, because 2 plus the square root of x plus 3 divided by itself is equal to 1. Okay. And so now the denominator is of the form a minus b times a plus b, and that FOILs to a squared minus b squared. Okay. So we end up with the difference of squares when we FOIL what's in parentheses in the denominator. So we have x minus 1 times 2 plus square root of x plus 3. Now, denominators of the form a squared minus, right, FOILs to a squared minus b squared, right? What's a? Plus 2. What's b? Square root of x plus 3. So a squared is equal to 2 squared, and b squared is the square root of x plus 3 squared. So now when we simplify the denominator, two squared is 4, and square root of x plus 3 squared is x plus 3. But you got to put the x plus 3 in parentheses, because you're subtracting x plus 3 from 4, not just x. Okay. And now you know out front of this left parentheses, that's the invisible minus 1. Right? So we distribute the minus sign inside the parentheses, left parentheses. left with 4 minus x minus 3, right? That's what the denominator simplifies to. After you distribute the minus sign. Alright, so the numerator is x minus 1 times 2 plus the square root of x plus 3. And 4 minus 3 denominator is 1. And so the denominator simplifies to 1 minus x. Okay. Now you might think we don't have a common factor in the numerator and denominator, but we do. X minus 1 over 1 minus x, what's that equal to? Negative 1. Okay. So let's prove that. Okay. So minus 1 times x minus 1. When you distribute the minus 1 inside the parentheses, minus 1 times x is minus x, and minus 1 times minus 1 is plus 1, and minus x plus 1 is the same as 1 minus x. I actually intend to do that the other way, but that's a true statement, right? Minus 1 times x minus 1 is equal to 1 minus x. If I multiply 1 minus x by negative 1, when I distribute the minus 1 inside, minus 1 times 1 is minus 1, minus 1 times minus x is plus x, and minus 1 plus x is the same as x minus 1. So 1 minus x and x minus 1 just differ by a minus sign, minus 1. Okay? So x minus 1 can be written as minus 1 times 1 minus x, and then we multiply that by 2 plus the square root of x plus 3 over 1 minus x. And now you can see the 1 minus x is canceled. And this is equal to minus 1 times 2 plus the square root of x plus 3. And instead of having minus 1 out here, you can just put a minus sign if you want. And you have minus 2 plus the square root of x plus 3. So x minus 1 over 1 minus x is equal to negative 1. And you can also write it as, well, that's what we have right here, right? X minus 1 over 1 minus x. That's just equal to negative 1. So you put negative 1 out front of the left parenthesis, and you have negative 1 times what's in parentheses here. Okay. So it's also true if I have something like, erase it. If I have something like 2x minus 5 over 5 minus 2x, that's also equal to negative 1, right? Because the numerator and the denominator just differ by a factor of minus 1, right? If I multiply the numerator by minus 1 and distribute the minus 1 inside parentheses, I end up with the denominator. All right, so this quotient reduces to this over here as long as x doesn't equal plus 1. I didn't write that over here, but you know, if x is equal to 1, we got 1 minus 1 in the denominator, which is 0, and you can't divide by 0. Okay. All right. Any questions on that, ladies and gentlemen? How we rationalize the denominator in that case? Okay. All right, so now let's do the limit. We have the limit as x approaches 1 of x minus 1 over 2 minus square root of x plus 3. So we do the direct substitution. We have 1 minus 1 over 2 minus the square root of 1 plus 3. And when you do the order of operations, right, you end up with 0 over 0. So this quotient is undefined at x equals 1, but the limit may still exist. Well, we learned, now in the limit, x never equals 1. It just gets close to 1. So we learned in this part up here that this quotient reduces to minus 2 plus the square root of x plus 3, provided x doesn't equal 1. Well, in the limit, x doesn't equal 1. Just gets close to 1. So this reduces to this. And now we can do the direct substitution. We have minus 2 plus square root of 1 plus 3. 1 plus 3 is 4, square root of 4 is 2, 2 plus 2 is 4, and so this simplifies to minus 4. So this quotient is undefined at x equals 1, but the closer x is to 1, the closer the value of this quotient is to minus 4. Okay. So that's the difference between at x equals 1 and near x equals 1. Okay. All right, any questions on that? Okay, one more and you'll have everything you need for the web assigned homework. So in this case, we're going to rationalize the numerator. And in Math 120, in Calc 1, when you're finding the derivative of a function using the definition of a derivative, you often have to rationalize the numerator. So rationalize the numerator is similar to rationalizing the denominator, except we're getting rid of the x in the, we're getting rid of the square root in the numerator. So we have square root of x minus 4 over x minus 16. So we want to rationalize the numerator, get rid of the square root of the numerator. Well, the conjugate of the numerator is square root of x plus 4. So we multiply top and bottom by the square root of x plus 4. So the numerator now is of the form a minus b times a plus b. And when you FOIL a minus b times a plus b, you get a squared minus b squared, right? Well, a in this case is square root of x, and b is equal to 4. So we have square root of x squared minus 4 squared. Right? A is square root of x, b is 4. So the numerator FOILs to square root of x squared minus 4 squared. The denominator, we'll just leave it as it is. You don't have to expand that. Students sometimes try to expand this and then they mess it up. Just leave it alone. So we have x minus 16 times square root of x plus 4. Well, square root of x squared is x, and 4 squared is 16, right? So the numerator simplifies to x minus 16. And in the denominator, we have x minus 16 times the square root of x plus 4. So now you see we've got a common factor in the numerator and denominator, x minus 16. Those two factors cancel as long as x minus 16 doesn't equal 0. Because if it equals 0, then the denominator equals 0. Which means x can't equal 16. So this quotient, original quotient, simplifies to 1 over the square root of x plus 4, provided x doesn't equal 16. So we got rid of the square root in the numerator, but now we have it in the denominator. Okay. Any questions on how we did that? Okay. So now we can evaluate the limit. The limit as x approaches 16, square root of x minus 4 over x minus 16. And so when we do the direct substitution, we have square root of 16 minus 4 over 16 minus 16, which is equal to 0 divided by 0, which is undefined. But in the limit, x never equals 16. It just gets close to 16. So this quotient simplifies to what's in the box over here. 1 over square root of 16 plus 4. Oops. I'm getting ahead of myself. 1 over square root of x plus 4. Okay. So this quotient simplifies to 1 over square root of x plus 4 as long as x doesn't equal 16, but in the limit, x never equals 16. Okay. And now we can do the direct substitution. And we have 1 over square root of 16 plus 4. Square root of 16 is 4. 4 plus 4 is 8. So this is just equal to 1/8. So this quotient is undefined at x equals 16. But the closer the value of x is to 16, the closer the value of this quotient is to 1/8. And so in the graph of this function, we know there's a hole in the graph at at the point 16, comma 1/8. Yes, sir.
Why wouldn't the square root of 16 optionally be -4, making it another undefined
No,
limit?
that's not the definition of square root.
Oh.
Yeah. So, square root of 16, 16 is written as 4 squared. 16 is a perfect square.
It couldn't be -4 squared because
It's not the definition of square root. Yeah. The number underneath the radical, right? Now, we're going to be doing quadratic formula, solving for x, right? And sometimes, when you substitute for a, b, and c in a quadratic formula, and after you substitute, you get square root of -16. Guys, remember that's equal to 4i. Okay? But square root of 16 is just equal to 4. Square root of -16 is 4i. Okay. Any other questions? Okay. So now you have everything you need to successfully complete the web assignment homework.